Gait motion is performed every day by able-bodied individuals. Proper gait will give the most efficient locomotion, which is the primary purpose of gait, or in other terms, walking. Gait motion is described as the coordinated motion of alternating movements between the lower two extremities, which allows for forward motion. This particular analysis will also include the role of the upper two extremities, which runs in opposition to the legs. We will look at both separately and then together. Gait motion is classified as a dynamic skill. For this particular assessment, the Rancho Los Amigos is being used as a baseline. This form of terminology has becoming more and more popular since the late 1980s and early 1990s, and is becoming the preferred form of analysis for gait motion. The Rancho Los Amigos breaks the gait motion cycle into two major phases, the stance and swing phase. The stance phase consists of 60% of the gait cycle, and the swing phase consists of the remaining 40%. The stance phase is then further broken down into initial contact, loading response, mid-stance, terminal swing, and pre-swing. The swing phase is further broken up into initial swing, mid-swing, and terminal swing. More terminology that will be useful is double support and gait cycle. Double support is described as when both your legs are in contact with the ground and are bearing some form of weight or force. Gait cycle is described as going through all the phases. One gait cycle is going through all the phases at once. When the heel of the leading foot hits the ground and ends when the same foot leaves the ground. The initial contact phase is when the foot or heel makes direct contact with the ground. Then the loading response is the initial double support period, which means it begins when the whole foot is on the ground and ends once the second foot leaves the ground. The mid-stance is when the foot making contact with the ground is taking all the weight and the other foot is in motion. This phase ends once the weight of the body is aligned over the forefoot. The next stance phase is terminal stance. Terminal stance is when the heel of the trailing foot is no longer in contact with the ground, but the toes are still in contact. Then ends once the leading foot comes in contact with the ground. The last stance phase is the pre-swing. Pre-swing is the second section of double support. The pre-swing begins with the toe of the trailing foot coming off the ground and the front foot going through the initial contact. This phase is when the weight is transferred from one foot to the next. The next phase is the swing phase. The first phase within it is the initial swing. The initial swing is the first third of the swing. Begins with the toe being lifted off the ground and ends when the swing foot is opposite of the stance foot. The next phase is the mid-swing and is the middle third of the swing. The mid-swing begins when the swing foot is opposite of the stance foot and ends with the swing foot is forward and tibia vertical, which is the hip and knee flexion postures are equal. The last third of the swing is covered by the terminal swing. The terminal swing begins with the vertical tibia and ends with the foot strike. This all consists of one gait cycle. The gait cycle corresponds only to the ankle, knee, and hip joint. The latter two are the only joints that will be described in this analysis. The joint motion is different in each of the phases along with the degree of motion. All of this information is according to the Rancho Los Amigos analysis for gait motion done by Washington University. During the initial contact of the swing phase, the hip is going through flexion at about 30 degrees. The knee is going through about 5 degrees of flexion. The next phase is the loading response, which the hip is doing flexion at about 30 degrees still, but may have a hint of extension at the end of this phase. The knee is going through flexion, still reaching about 20 degrees. The next phase with stance is mid-stance. The hip is extended almost to a neutral position. It moves for a total of about 25 degrees. The knee is also going through extension at about a total movement of about 12 degrees, ended at 8 degrees above neutral on the flexion side. There is a terminal stance, which the hip goes through 15 degrees of extension, finishing at about 10 degrees of extension. The knee during terminal stance is going through extension at first, then switches to flexion. Does about 3 degrees of flexion and then 7 degrees of flexion. The last stance phase of pre-swing, the hip is going through about 10 degrees of flexion to almost neutral, but still on the extension side. The knee is then going through rapid flexion of 28 degrees. This marks the end of stance phase and the beginning of swing phase. The first is the initial swing where the hip is going through rapid flexion at about 25 degrees. The knee is starting off with flexion, then moves to slight extension. 20 degrees of flexion, then 5 degrees of extension. The second swing phase is mid-swing. During this phase, the hip goes through flexion while slowing down. Does about 10 degrees of flexion. The knee during this phase will do rapid extension of 35 degrees. The final swing phase and the last phase in the gait cycle is terminal swing. The hip goes through extension of about 15 degrees, ending at 10 degrees of extension. The knee continues extending to natural about 20 degrees of extension, then does slight flexion of about 5 degrees. This all creates the joint motion in degrees of one gait cycle. Lower segments are being moved about the sagittal plane and transverse plane. The lower segments are also moved along the bilateral axis and vertical axis. The force-producing motion is by weight, normal reaction, friction, air resistance, and internal muscular force. This is breaking down the muscles active in the different phases in their contraction type. The initial contact phase, the gluteus maximus and medius, rectus femoris, vastus lateralis, bicep femoris, and tibialis, and anterior are active. All of the muscles during this phase are eccentric. The follow phase, loading response, is relatively the same as the previous, only excluding the gluteus maximus. The next phase is the mid stance, which only has the gluteus medius and calf muscles, which consist of the soleus and the gastrocnemius. All of the muscles being active in the mid stance are eccentric. During the terminal stance, the gluteus medius is the only muscle that is eccentric, and the iliopsis and calf muscles are concentric. The pre-swing has the rectus femoris being eccentric and the iliopsis and calf muscles as concentric. The initial swing has the rectus femoris as eccentric and the iliopsis and tibialis anterior as concentric. The mid-swing only has the bicep femoris and vastus lateralis as eccentric and iliopsis and tibialis anterior as concentric. The last phase is the terminal swing, which has the bicep femoris and vastus lateralis as eccentric and the tibialis anterior as concentric. This shows all the muscles being active during the individual phases. The next major section that needs to be described within the gait cycle is the mechanical aspect of gait. This will involve the types of forces in the different phases and the amount of force in the phases as well. This is according to Man-Soo Koo in his October 2010 article titled Plantar Pressure in Gait in Patients with Diabetes. Initial contact is 385 kilopascals. Loading response 321 kilopascals. Mid stance 147 kilopascals, and terminal stance up to 414 kilopascals. The forces that are involved in walking during the stance phase consist of weight, normal reaction, friction, air resistance, and internal muscular force. The amount of force being applied will determine velocity and energy it takes to go through one gait cycle. The less efficient someone is in placing their forces in walking, the more energy it will take to gain velocity and locomotion. This can be attributed in Newton's third law. During the initial contact, if the amount of force being applied from the body to the ground is being directed in an efficient way, then you will need to apply more unnecessary work to overcome this. This can be seen at push-off when the reaction force is greater than the gravitational force needed for balance. This creates a spring in a person's step. Friction is the force that is moving the gait cycle along. The stance phase has all friction being applied as well as some air resistance, but the swing phase has just air resistance acting upon the gait motion. The different phases within the stance phase will have different amounts of body weight acting upon the foot. If friction is not strong enough, then locomotion will decrease. For example, ice has less friction than grass, so your locomotion will decrease because there is not enough counter pressure due to little resistance from the surface. It is also important to keep in mind the direction of the ground reaction throughout the different phases. For instance, in heel strike, the ground force vector is going back up at an angle into the heel. In mid stance, the ground force vector is going straight up in the middle of the foot, and at push off, the ground force vector will come up at an angle where the metatarsals are in contact with the ground. These vectors will determine the efficiency of locomotion. Here we are viewing the upper body and observing the shoulder girdle as well as the elbow joint during the walking gait. Although these segments seem to play a small part in the role of the walking gait, they are actually a big contributor by allowing us to move with more rhythm and balance, conserving our energy. This skill is a dynamic skill and consists of each arm swinging through the anterior of the body with the opposite leg and then returning back to the neutral position when the other arm and legs are making their forward motion. There are two separate phases to the walking gait in the upper body: the forward swing and the back swing. The back swing consists of the shoulder and elbow joints extending as they return to their neutral positions. The forward swing consists of the shoulder and elbow joints flexing as the arm swings anteriorly. The joints that are involved are the acromioclavicular joint, the glenohumeral joint, also known as the shoulder girdle, and the elbow joint. The acromioclavicular joint's function is stabilization, while the glenohumeral joint rotates the humerus. The elbow joint flexes and extends during the walking gait. It flexes during the forward swing and extends during the back swing. During the walking gait, the arms move along the sagittal plane and use the medial-lateral axis. While the forward swing flexion is in progress, the prime movers of the shoulder girdle are the coracobrachialis, pectoralis major, the upper fibers at 60 degrees flexion, and the anterior deltoid. The prime movers of the elbow joint during the forward swing flexion are the brachialis, brachioradialis, and the biceps brachii. During the backswing extension, the prime movers of the shoulder girdle are the latissimus dorsi, teres major, posterior deltoid, and the pectoralis major, the lower fibers to the neutral position. The prime movers of the elbow joint during the backswing are the triceps brachii. The contraction type for the prime movers of the forward swing and the shoulder girdle are the concentric during the forward swing and eccentric during the backswing. The prime movers for the backswing and the shoulder girdle are concentric during the backswing and eccentric during the forward swing. The prime movers of the elbow joint during the forward swing are concentric during the forward swing and eccentric during the backswing. The prime movers of the elbow joint during the backswing are concentric during the backswing and eccentric during the forward swing. Taking in all this information, you are probably asking yourself, why do we swing our arms during the walking gait, and what is the point? The point of swinging our arms back and forth during the walking gait is to give us rhythm and balance while we achieve efficient locomotion. What's wrong? This is an example of an improper gait cycle. This person has a waist lean. There is anterior pelvic tilt, which puts the new center of gravity in front of the body. This puts significant strain on the lower back. Compared to the proper way to walk, this person has a spring to their step. This is attributed to the inefficient placement of force and reaction forces. The body weight is pushed forward thanks to the pelvic tilt. This means that the person needs greater inertia to increase locomotion. To get rid of this, you need to tighten your abdominal muscles and straighten your posture. If your buttocks stuck out with the posture straight, waist lean would not occur. But since the posture is not straight in this individual and the buttock still sticks out, this will create an improper gait cycle.